My name is Manjula. I worked as assistant professor in Department of ECE. Now I am explaining about rectifiers. So what is meant by rectifier? What is the function of rectifier? What are the different types of rectifiers? What are the parameters in rectifiers? So what is the definition of rectifier? Rectifier is an electronic device. It is used to convert alternating current into direct current. So what is meant by rectification? The process of conversion of alternating current into direct current is known as rectification. What are the different types of rectifiers? Half-wave rectifier, full-wave rectifier, bridge rectifier. So for this rectifier, input signal is nothing but AC signal, output is nothing but pulsating DC. So rectifier is used to convert alternating current into not pure DC, pulsating DC. What is meant by pulsating DC? Pulsating DC means it contains some unwanted ripples. Our aim is to avoid these unwanted ripples by using filter. So basically, this half-wave rectifier contains one transformer, one diode, and one resistor. So this is the circuit diagram of half-wave rectifier. This half-wave rectifier contains step-down transformer. Step-down transformer means number of windings in the secondary is less than the primary. So at the primary of the transformer, we are applying AC signal. At the secondary, terminal A is connected to anode of the diode, cathode is connected to load RL. Load RL other end is connected to terminal B. Terminal A and B are secondary winding terminals. So during the positive half cycle, what happens to the circuit? During negative half cycle, what happens to the circuit? So during the positive half cycle, terminal A becomes positive, terminal B becomes negative. So when terminal A becomes positive means terminal A is connected to anode of diode D. So diode D is in forward bias. When diode D is in forward bias, it conducts. So it is in on condition. So some current is passing through diode D. Same current is also passing through load RL. Why? Because this diode D and the load RL, these two are connected in series. So same current is passing through load RL also. So during the positive half cycle, corresponding output V0 equal to IL multiply with RL. IL is nothing but current passing through load RL. RL is nothing but resistance of the resistor RL. So V0 equal to output voltage V0 equal to IL multiply with RL. So during the positive half cycle, we can get the corresponding output. So during the negative half cycle, what happens to the circuit? During negative half cycle, terminal A becomes negative. When terminal A becomes negative means negative terminal is connected to anode of diode D. So diode D is in reverse bias. When diode D is in reverse bias, it acts as open circuit. Whenever it acts as open circuit, current equal to 0. It does not conduct, current equal to 0. So whenever current equal to 0, what is the corresponding output voltage V0? V0 equal to IL multiply with RL. Suppose RL equal to 1 kilo ohm. 1 kilo ohm multiply with what is IL value? IL equal to 0. So RL multiply with 0 equal to 0. So corresponding output V0, output voltage value equal to 0 volts only. So during the positive half cycle, you can get the corresponding output. During negative half cycle, corresponding output equal to 0 volts. So during the positive half cycle, corresponding output equal to positive half cycle. During negative half cycle, corresponding output voltage equal to 0 volts. So what are the advantages of half-wave rectifier? So in this half-wave rectifier, we are used only one diode, requires only one diode. So cost is also less. It is suitable for low power applications. Circuit is also very simple circuit. These are the advantages of half-wave rectifier. So what are the disadvantages of half-wave rectifier? Low rectification efficiency, that efficiency value equal to 40.6%. Ripple factor, high ripple factor. The ripple factor value is equal to 1.21. Low average DC output voltage, poor voltage regulation. TUF, transformer utilization factor is low, that is 0.287. Only 50% of AC signal is converted into DC only. Requires additional filters to obtain smooth DC output. So what are the applications of half-wave rectifier? Half-wave rectifiers are used in low power DC power supplies, battery charging circuits, signal detection, electronic measuring instruments. These half-wave rectifiers are used in educational laboratory experiments, small electronic devices. So for this half-wave rectifier, now calculate what is DC output value, what is VDC value, what is IDC value, what is the ripple factor value, what is the efficiency. So now all these parameters are calculated one by one. So first one is average DC output voltage. Average DC output voltage. So here input signal is nothing but, for half-wave rectifier, input signal is nothing but AC signal. Corresponding output is nothing but from 0 to pi. We can get the corresponding output. Pi to 2 pi, corresponding output equal to 0. So from 0 to pi, you can get the corresponding output. From pi to 2 pi, it is in reverse bias. Diode is in reverse bias. So corresponding output equal to 0 volts. So from 0 to 2 pi, how can you calculate average or DC output voltage? From 0 to 2 pi, area covered by this signal from 0 to 2 pi by 2 pi minus 0. So here signal is represented as output voltage V0 equal to Vm sin omega t. Here Vm is nothing but maximum voltage or peak voltage value. Here Vm is nothing but maximum voltage or peak voltage value. So output signal is represented as V0 equal to Vm sin omega t. So from 0 to pi, you can get the corresponding output. So V0 equal to, how can you represent the output signal? V0 equal to Vm sin omega t, 0 less than or equal to omega t less than or equal to pi. From pi to 2 pi, what is output signal? 0. So when V0 equal to 0, pi less than or equal to omega t less than or equal to 2 pi. Now how can you calculate average value or VDC value? VDC or VAC, V average value equal to integral of 0 to 2 pi V0 d omega t by upper limit minus lower limit 2 pi minus 0. So now it becomes 1 by 2 pi integral of 0 to pi. Now split this 0 to 2 pi integral into 0 to pi plus pi to 2 pi. So now split integral of 0 to 2 pi split into two parts. 1 by 2 pi integral of 0 to pi. What is V0 value? Vm sin omega t. Vm sin omega t d omega t plus integral of pi to 2 pi V0 d omega t. What is V0 value? Pi to 2 pi 0. So 0 d omega t. So second term becomes 0. Now 1 by 2 pi integral of 0 to pi Vm sin omega t d omega t. Here Vm is nothing but peak voltage or maximum voltage. It is nothing but one constant value. So Vm by 2 pi integral of sin omega t d omega t. What is the integration of sin omega t? Minus cos omega t. Now apply the limits. So Vm by 2 pi minus, what is upper limit? Pi. So Vm by 2 pi minus cos pi minus cos 0. What is cos pi value? Cos pi equal to minus 1, cos 0 equal to 1. So Vm by 2 pi minus of minus 1 plus 1 minus of minus plus 1. So Vm by 2 pi multiply with 2. 2 get cancelled. So V average or VDC value equal to Vm by pi only. What is pi value? 3.14. So Vm by 3.14. So that becomes 0.318 multiply with Vm. Vm is nothing but maximum voltage or peak voltage value. Next, average or DC current value. How can you calculate average or DC current value? IDC equal to or I average equal to or IDC equal to DC current value. IDC equal to, by using Ohm's law V equal to I multiply with R. Therefore I equal to V by R. So in this one, calculate DC value. Therefore IDC equal to VDC by R. Already calculate VDC value. What is VDC value? Vm by pi. Now substitute VDC value in this formula. Vm by pi by R. Now it becomes Vm by pi multiply with R. Vm by R is nothing but Im. V by R is nothing but current value. Therefore Vm by R is nothing but Im. Therefore I average equal to Im by pi. Next, RMS value. Root mean square value. How can calculate root mean square value for this half-wave rectifier? First of all, take the root value, then mean. What is the formula for square root of root mean square? First of all, take the mean value, then square root. So IRM is equal to square root of 1 by 2 pi integral of 0 to 2 pi Im sin omega t d omega t whole square. So here I is nothing but Im sin omega t 0 less than or equal to omega t less than or equal to pi. Output I equal to 0, pi less than or equal to omega t less than or equal to 2 pi. So during the negative half cycle, current value equal to 0. That's why I equal to 0 from pi less than or equal to omega t less than or equal to 2 pi. I equal to Im sin omega t from during the positive half cycle current diode conducts. So current value I equal to Im sin omega t 0 less than or equal to omega t less than or equal to pi. Therefore, IRM is equal to 1 by 2 pi integral of, again split this 0 to 2 pi into two parts, 0 to pi, pi to 2 pi. Therefore, 1 by 2 pi integral of 0 to pi Im sin omega t whole square. Im sin omega t whole square is nothing but Im square sin square omega t d omega t plus pi to 2 pi. Pi to 2 pi, what is the current value? 0. So, integral of pi to 2 pi 0 d omega t. Now second term becomes 0. Therefore, 1 by 2 pi integral of 0 to pi Im square sin square omega t d omega t. How can I write this sin square omega t? Im is nothing but constant value. So, Im square by 2 pi. Im square by 2 pi. How can I write this sin square omega t? 1 minus cos 2 omega t by 2. Therefore, Im square by 2 pi integral of 0 to pi sin square omega t. How can I write this one? 1 minus cos 2 omega t by 2. 1 by 2 is nothing but one constant value. So, Im square by 4 pi integral of 1 d omega t minus integral of cos 2 omega t sin 2 omega t. Again take the 2 omega t. 2 omega t is nothing but by 2, 1 by 2. So, Im square by 4 pi. Now apply the limits. For the first term, upper limit is pi. Pi minus second limit is nothing but 0. So, pi minus 0. For the second term, both upper limit value as well as the lower limit value both are becomes 0. 2 pi 0, sin 2 pi 0, sin 0 0. So second term becomes 0 for both upper limit as well as the lower limit. So Im square by 4 pi multiply with pi. Pi get cancelled. Now it becomes Im square by 4 square root or whole power 1 by 2 both are same. Square root of Im square by 4 becomes Im by 2. Therefore, IRM is equal to Im by 2 only. Root mean square current value. That value is equal to Im by 2. What is Im value? Maximum current value. So, it is nothing but one constant value. Then you have to substitute that Im value in this formula. Then calculate root mean square current value. Next, calculate VRMS value. Root mean square voltage value. VRM is equal to, by using Ohm's law, V equal to I into R. I multiply with R. So, here VRM is equal to, now consider current value is also root mean square current value only. IRMS is always calculated, already calculated. So now substitute VRM is equal to IRMS multiply with R. What is IRMS value? What is IRMS value? IRMS equal to Im by 2. Now substitute Im by 2 or IRMS equal to Vm by R. From this formula, IRM is equal to Im by 2. So, VRM is equal to IRMS multiply with R. What is IRMS? IRM is equal to Im by 2. Im by 2. So, Im multiply with R equal to Vm. So, Vm by 2. Root mean square VRM is equal to IRMS multiply with R. What is IRMS value? IRM is equal to Im by 2. Now, substitute in this formula. Im by 2 multiply with R. R into Im equal to, again that value equal to Vm. So, Vm by 2. So, VRM is equal to Vm by 2. Vm is nothing but maximum voltage value. That is one constant value. Now, substitute that Vm value in this formula. Then calculate root mean square voltage value. So, VRM is equal to Vm by 2 for half-wave rectifier. Now, calculate form factor. What is the definition of the form factor? It is the ratio of RMS value to average value. So form factor equal to Vrms by V average. V average or VDC value. Vrms value is already calculated. VDC value is also calculated. Now substitute these two values in this formula. What is Vrms? Vm by 2. What is VDC or V average value? Vm by pi. Now substitute these two values in this formula. Therefore form factor equal to Vrms equal to Vm by 2 by V average equal to Vm by pi. Now it becomes Vm by 2 multiply with pi by Vm. Vm get cancelled. Therefore, form factor equal to pi by 2. What is pi value? 3.14. So 3.14 by 2. Now that value equal to 1.57. Now calculate efficiency value. What is the formula for efficiency? Efficiency is nothing but it is the ratio of output power to input power. Here output power is nothing but AC value. Output is nothing but DC, input is nothing but AC. Therefore, efficiency equal to PDC by PAC. The formula for efficiency is, it is the ratio of output power to input power. Here output power is nothing but DC, PDC. Input power is nothing but AC, PAC. So, efficiency equal to PDC by PAC. In terms of percentage, multiply with 100. So, all of you well known what is formula for power P? Power P equal to V multiply with I, VI. So, how can you calculate PDC value? PDC equal to power P equal to V multiply with I. Therefore, PDC equal to VDC multiply with IDC. Again, VDC equal to V equal to I multiply with R. Again, VDC equal to IDC into R. So, power PDC equal to, what is formula for power P? V into I. So, power PDC equal to VDC multiply with IDC. Again, VDC equal to IDC into R. So, IDC multiply with IDC equal to IDC square R. Therefore, PDC equal to IDC square R by input power is nothing but AC, PAC. How can you calculate PAC value? Again, PAC equal to power P equal to V multiply with I. Therefore, PAC equal to Vrms multiply with I. Both are RMS values only. Again, V equal to I into R. Therefore, I into I equal to IRMS square R. So, PDC equal to IDC square R by input power is nothing but AC signal. So, PAC equal to Vrms multiply with IRMS. Vrms multiply with IRMS. Again, Vrms equal to IRMS multiply with R. So, IRMS equal to IRMS square multiply with R. RR get cancelled. Again, substitute IDC value and IRMS value. IDC value is also calculated. IRMS value is also calculated. For half-wave rectifier, what is IDC value? For half-wave rectifier, IDC equal to IM by pi. IRMS equal to IM by 2. Now substitute these two values in the above formula. What is IDC? IM by pi. So IDC square equal to IM by pi whole square. IM square by pi square by IRMS equal to IM by 2. So IRMS square equal to IM square by IM by 2 whole square. That becomes IM square by 4. Therefore, IM square by pi square multiply with 4 by IM square. IM square get cancelled. Now it becomes 4 by pi square multiply with 100. Pi is nothing but 3.14. Therefore, 4 by 3.14 whole square into 100. So that value equal to 40.56. So how much amount of, what about remaining 60%? So by using this half-wave rectifier, only 40% of voltage signal, 40% of AC signal is converted into DC. What about remaining 60%? Remaining 60% is nothing but output contains 60% of ripples. Our aim is to avoid these ripples, unwanted AC component. For that one, go for filter circuits. For this half-wave rectifier, across this load RL, connect one capacitor. So what is the efficiency of the half-wave rectifier? Efficiency of the half-wave rectifier is 40.56 only. That means only 40% of AC signal is converted into DC. What about remaining 60%? That is nothing but unwanted AC component. Our aim is to avoid this unwanted AC component. How can you avoid this unwanted AC component? By using filter circuits. What is meant by filter circuit? Across this load RL, connect one capacitor parallel to the load RL. So this is the half-wave rectifier. At the primary of the transformer, we are applying the AC signal. At the load RL, you can calculate the output voltage V0 value. What is meant by filter circuit? Across this resistor RL, connect one capacitor parallel to the load. Then what happens? Corresponding output, half-wave rectifier corresponding output is nothing but 0 to pi. You can get the corresponding output, pi to 2 pi. That value equal to 0. So if you connect one capacitor parallel to the load, then what happens? 1/4 of the, during the past half cycle, from 1/4 to maximum peak, capacitor is charges. Again, it is discharges up to 1/4 cycle of the next past half cycle. Again charges, again discharges. So, if we connect one capacitor parallel to the load RL, what is the corresponding output? Corresponding output will be like this. So, it is very close to DC value. Pure DC is nothing but just a straight line. But here also there is some unwanted AC component will be there. If we connect one capacitor or in filter circuit, that AC component value will be reduced. It is very close to pure DC or it is very close to DC value. So here also if we connect one capacitor parallel to the load RL, then unwanted AC component or unwanted ripples will be reduced. So this is the corresponding half-wave rectifier with the filter. This is the corresponding output. So it is very close to DC value. Pure DC is nothing but just a straight line. So it is very close to straight line. So unwanted AC component or ripples are reduced if you connect one capacitor parallel to the load RL. Now calculate ripple factor value for half-wave rectifier. How can you calculate ripple factor value? Current value is given by ripple factor. It is the ratio of RMS value of AC component to DC component of the output. So ripple factor equal to, it is represented as gamma. So ripple factor gamma equal to IAC by IDC. Here IDC is nothing but average value, IAC is nothing but RMS value. So IRMS by I average or IDC value. Total current is nothing but, it is the sum of AC component as well as the DC component. Therefore, current I equal to IAC plus IDC. IAC is nothing but AC value, current AC value, AC current component value, IDC is nothing but DC value. Therefore, from the above formula, IAC equal to I minus IDC. How can you calculate? How can you calculate RMS value? IRMS equal to square root of 1 by 2 pi integral of 0 to pi IRMS square d omega t. Again IRMS equal to I minus IDC whole square d omega t. Here square root is nothing but whole power 1 by 2. So 1 by 2 integral of 0 to 2 pi I minus IDC whole square equal to I square plus IDC whole square minus A minus B whole square equal to A square plus B square minus 2AB. You can apply this formula. I square plus IDC square minus 2I IDC d omega t whole power 1 by 2. Or simply you can calculate, how can you calculate this ripple factor value? Ripple factor IRMS equal to square root of, or ripple factor gamma equal to square root of IRMS by IDC whole square minus 1. IRMS value and IDC value, both values are calculated. What is IRMS value? Ripple factor gamma equal to IRMS by IDC whole square minus 1. So ripple factor equal to IRMS square minus IDC square by IDC. How can you write this formula? IRMS square minus IDC square by IDC. How can you rewrite this formula? IRMS by IDC whole square minus 1. IRMS value and IDC value, both values are already calculated in the case of half-wave rectifier. What is IRMS? What is IDC value? IRMS equal to IM by 2. IDC equal to, what is IDC value? I average value. What is IDC value? IM by pi. Now substitute IM by pi. IRMS equal to IM by 2. Now substitute these two formulas. So IRMS by IDC whole square. IRMS by IDC whole square minus 1. What is IRMS by IDC whole square? IRMS by IDC whole square is nothing but form factor. IRMS by IDC whole square is nothing but form factor. Form factor value is already calculated. Now substitute that form factor value in this formula. Therefore, gamma equal to square root of form factor whole square minus 1. What is form factor value? 1.57 whole square minus 1. That value equal to 1.21. So, ripple factor value for half-wave rectifier is 1.21. Efficiency value, this value is already calculated. Next one is full-wave rectifier. So, what is meant by full-wave rectifier? Why we go for this full-wave rectifier? So, by use this half-wave rectifier, only 40% of AC signal is converted into DC. So, remaining 60% contains the AC component. So, in full-wave rectifier, to overcome this problem, we go for the full-wave rectifier. In full-wave rectifier, for this full-wave rectifier, what are the components are required? Why we go for this full-wave rectifier? In this full-wave rectifier, we are used two diodes, diode D1 and D2, one transformer and load resistor RL. In the case of with capacitor, in the case of filter circuit, one capacitor is also required. So, in full-wave rectifier, this full-wave rectifier is also used for to convert. Here input signal is nothing but AC signal. So, convert AC signal into DC signal. Convert AC into DC. So, what are the different types of full-wave rectifiers? Center tap full-wave rectifier. Next one is bridge rectifier. So, this is the circuit diagram of full-wave rectifier. What is the construction of full-wave rectifier? This is the transformer. Transformer contains the two windings, primary winding, secondary winding. At the primary, we are applying AC signal. This is the AC signal. At the secondary, there are two terminals are there, terminal 1, terminal 2 or terminal A, terminal B. So, this full AC signal contains both positive half cycle as well as the negative half cycle. So, here we are used two diodes, diode D1 and D2. This is anode, this is cathode. Here also this is anode, this is cathode. Anode means positive, cathode means negative. Two cathodes are connected to one point. Next, from this point connect one load resistor RL. This load resistor is connected to center tap. This transformer is nothing but a center tap transformer. So, this load RL is connected to center tap. Now, this is the construction of full-wave rectifier. Now, what is the operation of the full-wave rectifier? Here input is nothing but AC signal. It contains both positive half cycle as well as the negative half cycle. So, during the positive half cycle means from 0 to pi. Negative half cycle means pi to 2 pi. So, from 0 to pi, what happens to the circuit? Pi to 2 pi. What happens to the circuit? So, during the positive half cycle, terminal A becomes positive, terminal B becomes negative, or terminal 1 becomes positive, terminal 2 becomes negative. When terminal 1 becomes positive, this terminal 1 is connected to anode of diode D1. So, diode D1 is in forward bias. So, during the positive half cycle, terminal 2 becomes negative. So, here negative is connected to anode of diode D2. So, diode D2 is in reverse bias, diode D1 is in forward bias. When diode D1 is in forward bias, it acts as closed circuit. When diode D is in reverse bias, it acts as open circuit. So, during the positive half cycle, diode D1 is in on condition, diode D2 is in half condition. It acts as an open circuit, so it is in off condition. So, during the positive half cycle, diode D1 is in forward bias, so it conducts. So, some current is passing through from this diode D1 to load RL. Same current is also passing through load RL. Why? Because these two are connected in series. So current is passing from this diode D1 to load RL, from this RL to this center tap. In this way, loop will be closed. Whatever the diode D2, diode D2 is nothing but it is in reverse bias. Terminal 2 or terminal B becomes negative. During positive half cycle, terminal 2 becomes negative. Negative is connected to anode of diode D2. Now diode D2 is in reverse bias. Whenever it is in reverse bias, it acts as an open circuit. Whenever it acts as an open circuit, how much amount of current is passing through diode D2? 0. So, during the positive half cycle, by using this diode D1, you can get the corresponding output. From 0 to pi, you can get the corresponding output. Next, during negative half cycle means pi to 2 pi. During negative half cycle, terminal A becomes negative, terminal B becomes positive. When terminal A becomes negative means negative is connected to anode of diode D1. So diode D1 is in reverse bias. Whenever it is in reverse bias, it acts as an open circuit. During negative half cycle, terminal 2 or terminal B becomes positive. So positive is connected to anode of diode D2. So diode D2 is in forward bias. So it acts as a closed circuit. So during negative half cycle, diode D2 is in on condition, diode D1 is in off condition. So during negative half cycle, diode D2 is in on condition, it acts as a closed switch. Now current is passing from diode D2 to load RL, from this RL to center tap, from this center tap to this one. So in this way, loop will be closed. So during the negative half cycle, by using this D2, you can get the corresponding output. Diode is nothing but unidirectional. So during the positive half cycle, during the negative half cycle, you can get the corresponding output in unidirectional. So by using this full wave rectifier, during the positive half cycle, you can get the corresponding output. During negative half cycle also, you can get the corresponding output. That means by using these two diodes, this AC signal is converted into DC. Pure DC is nothing but straight line, but in this one also there are some unwanted AC component with unwanted, some ripples are there. Output is nothing but like this means there are some ripples are there. Ripples is nothing but unwanted AC component. Our aim is to avoid this unwanted AC component. How can avoid this unwanted AC component? Connect one capacitor parallel to the load RL like this. So these two cathodes are connected to one single point. From this point to connect load RL. For this load RL, connect one capacitor parallel to the load RL. Again, this is C and load RL. These two are connected to center tap. Then what happens? If you connect one capacitor parallel to the load RL, then what happens? One fourth of the positive half cycle to maximum peak, capacitor charges, again discharges, again charges. Now this one is charges, again discharges, charges, discharges. So waveform will be like this. If you connect one capacitor parallel to the load RL, then output will be like this. It is very close to pure DC is nothing but just a straight line. So it is very close to straight line. That means ripples are reduced if you connect one capacitor parallel to the load RL. So unwanted AC component will be reduced if you connect one capacitor parallel to the load. So in filter, if you connect capacitor or filter, so in filter circuits, reduce the DC value, reduce the AC component value at the output side. So by using filter circuit, or if you connect one capacitor parallel to the load RL, then AC component value will be reduced or ripples are reduced, DC component value will be increased. This is the operation of full wave rectifier. So by using full wave rectifier, during the positive half cycle is also AC component is converted into DC. During negative half cycle is also converted into DC. So by using this full wave rectifier, you can reduce the ripples or you can reduce the AC component value, increase the DC value. That is the main advantage. So this is the AC signal. Input signal is nothing but this one, AC signal. So during the positive half cycle, you can get the corresponding output. During negative half cycle, diode D2 is in on condition. So you can get the corresponding outputs like this. So during the positive half cycle, diode D1 is the non-condition. So you can get the from 0 to pi, you can get the corresponding output. Next, during negative half cycle, diode D1 is in off condition. So you can get, it is in off condition. Next, during the positive half cycle, diode D1 is in on condition. So you can get the corresponding output from 0 to pi. Next, during this negative half cycle, diode D1 is in off condition. Next, during this half cycle, you can get the corresponding output. During this positive half cycle, you can get the corresponding output. During this positive half cycle, you can get the corresponding output. Next, during the negative half cycle, diode D2 is in on condition. So, during negative half cycle, whenever diode D2 is in on condition, you can get the corresponding output like this. You can combine these two, total corresponding output will be like this. So this is the AC signal. By using filter circuit, or if you connect one capacitor parallel to the load RL, then waveform will be like this. So 1/4 of the positive half cycle, from this 1/4 to maximum peak capacitor charges. Again, up 1/4 of the positive half cycle to maximum peak charges. Again discharges, again charges, again discharges, charges, discharges, charges, discharges. So waveform will be like this. So ripples are reduced. Again calculate all these parameters. What is average value, IDC value, what is IRMS value, IDC, IRMS, ripple factor value, efficiency. For this full wave rectifier is also calculated all these parameters one by one. Now calculate DC V average value or VDC value for full wave rectifier. For this full wave rectifier, what is the corresponding output? Output will be like this. Here Vm is nothing but maximum voltage or peak voltage. 0 to pi, it is nothing but during the positive half cycle. Pi to 2 pi, it is nothing but from 0 to, this is nothing but during the negative half cycle corresponding output. So output waveform will be like this. Now calculate, for this, calculate average value or VDC value. V0 equal to, output voltage V0 equal to Vm sin omega t. Vm is nothing but maximum voltage. This is the maximum voltage. From this 0 to this one, this is the maximum voltage. Output voltage V0 equal to Vm sin omega t. 0 less than or equal to omega t less than or equal to pi. V average or VDC value equal to 1 by pi integral of 0 to pi Vm sin omega t d omega t. Vm is nothing but maximum voltage value. This is nothing but one constant. So Vm by pi integral of 0 to pi sin omega t d omega t. What is the integration of sin omega? Minus cos omega. Now apply the limits. Lower limit is 0, upper limit is nothing but pi. So Vm by pi minus cos pi minus cos 0. What is cos pi value? Minus 1. What is cos 0 value? 1. So minus of minus 1 equal to plus 1, minus minus plus cos 0 equal to 1. Now it becomes Vm by pi multiply with 2. So V average or VDC value equal to 2 Vm by pi. So in this full wave rectifier, why we can consider only 0 to pi? What is the average of this one? Average of this one is nothing but 1 by 2 pi integral of 0 to 2 pi Im sin omega t or Vm sin omega t d omega t. So how can you calculate average value? 1 by 2 pi integral of 0 to 2 pi Im sin omega t. How can you split this one? Again, Im by pi integral of 0 to pi Im sin omega t plus integral of pi to 2 pi Vm sin omega t d omega t. Both are same. That's why you can get the 2. Then 2 get cancelled. 2 get cancelled. Now VAC or VDC equal to 1 by pi integral of 0 to pi Vm sin omega t d omega t only. In full wave rectifier, average value VAC or VDC equal to 1 by pi integral of 0 to pi Vm sin omega t d omega t. Vm is nothing but constant value or peak voltage value. So Vm by pi integral of 0 to pi sin omega t. What is integration of sin omega? Minus cos omega. Now apply the limits. Therefore, V average or VDC value equal to 2Vm by pi. Now calculate IDC or I average value. I average equal to V average by R. What is V average or VDC value? VDC equal to 2Vm by pi. Now substitute this VDC value in this formula. VDC or V average both are same. So 2Vm by pi. Again Vm by R equal to Im. Therefore I average or IDC equal to 2Im by pi. Therefore I average equal to IDC equal to, so I average equal to 2Im by pi for full wave rectifier. Next calculate root mean square value. So IRMS equal to, what is formula for IRMS value? Root mean square value. Root mean square load current voltage value. How can you calculate IRMS value? IRMS equal to 1 by pi integral of 0 to pi Im sin omega t whole square. Square root of 1 by pi integral of 0 to pi Im sin omega t whole square d omega t. Square root is nothing but whole power 1 by 2. So 1 by pi integral of 0 to pi. Here now substitute Im value. What is Im value? What is the current I value? I equal to Im sin omega t. Im sin omega t whole square equal to Im square sin square omega t d omega t. Square root is nothing but you can write whole power 1 by 2. Im is nothing but constant value. So Im square by pi integral of 0 to pi sin square omega t d omega t. How can I write this sin square omega t? 1 minus cos 2 omega t by 2. Therefore, Im square by pi integral of 0 to pi sin square omega t is nothing but 1 minus cos 2 omega t by 2. So Im square by 2 pi integral of 0 to pi 1 d omega t minus integral of 0 to pi cos 2 omega t d omega t. Integral of 1 d omega t is nothing but omega t. So Im square by 2 pi integral of 1 d omega t is nothing but omega t minus integral of cos 2 omega t is nothing but sin 2 omega t. Again take this to this 2 omega t is nothing but 2 by 2. So Im square by 2 pi integral of omega t is nothing but pi minus sin 2 omega 2 by 2. Now apply the limits. Upper limit is nothing but pi, lower limit is nothing but 0. So for the second term, for both upper limit as well as the lower limit becomes 0. Why? Because sin 2 pi 0, sin 0 0. So for the second term, for both upper limit as well as the lower limit, both are becomes 0. What about the first term? First term is nothing but omega t. Upper limit is nothing but pi. So Im square by 2 pi minus omega t is nothing but 0. So for the second term, upper limit as well as the lower limit, both are becomes 0. Omega t is nothing but pi. Upper limit is nothing but pi minus lower limit is nothing but 0. So Im square by 2 pi into pi. Pi get cancelled. Im square by 2 whole power 1 by 2. Or square root of Im square by 2. Square root of Im square by 2 is nothing but Im by root 2. That is nothing but IRMS value. So for full wave rectifier, IRMS equal to Im by root 2. Here sin 2 pi 0 for upper limit. For lower limit sin 0 0. So for the second term, both upper limit value as well as the lower limit value becomes 0. Therefore IRMS equal to Im by root 2. Next calculate VRMS value. VRMS equal to, by using Ohm's law, V equal to I into R. I multiply with R. Therefore VRMS equal to IRMS multiply with R. IRMS value is already calculated. What is IRMS value? Im by root 2. Now substitute this IRMS value in this formula. Therefore VRMS equal to IRMS multiply with R. IRMS equal to Im by root 2. Again Im multiply with R equal to Vm. Therefore IRM is equal to Vm by root 2. Vm is nothing but maximum voltage. Now substitute this maximum voltage value in this formula. Then you can get the VRMS value. Now calculate efficiency value. How can you calculate efficiency? What is the formula for efficiency? It is defined as It is the ratio of output power to input power. So, efficiency equal to PDC by PSC. What is PDC? PDC equal to VDC multiply with I. Again, VDC equal to IDC into R. Therefore, PDC equal to IDC square R by, here input AC power. Input is nothing but AC signal. Therefore, VAC equal to, how can you calculate this PAC value? PAC equal to IRM square R. Now substitute IDC and IRMS. What is IDC value? IDC equal to 2Im by pi, IRMS equal to Im by root 2. Now substitute these two values in this formula. RR get cancelled. So IDC equal to 2Im by pi, IRMS equal to Im by root 2. Now substitute these two values in this formula. Im square get cancelled. Now it becomes 8 by pi square. Multiply with 100. So efficiency equal to pi is nothing but 3.14. So efficiency equal to 81.13. So in previous condition, in half-wave rectifier, efficiency equal to 40% only. So 40% of AC signal is converted into DC. But in this one, by using full-wave rectifier, 80% of AC signal is converted into DC. What about remaining 20%? Remaining 20% is nothing but unwanted AC component or ripples. So by using full-wave rectifier, efficiency value will be increased, double that of the half-wave rectifier. So 80% of AC signal is converted into DC by using this full-wave rectifier. Remaining 20% is nothing but unwanted AC component or ripples. Form factor equal to, it is the ratio of VRMS to V average value. Now substitute VRMS and V average in this above formula. What is VRMS value? Vm by root 2. What is V average value or VDC value for full-wave rectifier? 2Vm by pi. Now substitute VRMS and VDC value in this above formula. VRMS equal to Vm by root 2. VDC or V average equal to 2Vm by pi. These two values are already calculated. So Vm by root 2 by V average equal to 2Vm by pi. Vm get cancelled. Now it becomes pi by 2 root 2. That value equal to 1.11. Form factor equal to 1.11. Ripple factor equal to square root of VRMS by VDC whole square minus 1. VRMS by VDC whole square is nothing but form factor. Form factor value is already calculated. Now substitute this form factor value in this formula. Therefore, ripple factor equal to square root of VRMS by VDC whole square minus 1. Again, VRMS by VDC whole square is nothing but form factor. Therefore, ripple factor equal to form factor whole square minus 1. Form factor value is already calculated. Now substitute form factor value in this formula. So that value equal to square root of 1.11 whole square minus 1. That value equal to 48.1%. So ripple factor for this full-wave rectifier is 48.1%.